There'll be a link in the description field down there to download a cool white paper from AWS MarketSpace about agentic AI and all that kind of stuff, which doesn't enter into this discussion exactly, but who knows? With EBOM and MBOM, you never know. You never know where it's going to go, right? That's we have an extremely diverse and interesting panel today. Some of the regulars, of course, Brian and Ken and Dr. Patrick and Jos and Oleg, but Jonathan Scott, who we've had the pleasure of welcoming at least twice so far, once or twice.
Yeah,
and I would like first to introduce David, who is our manufacturer, David Schultz from Amarak. I think did I pronounce that right?
Yeah, Amarak Stackworks, yeah.
Amarak Stackworks, who is our first guy who's coming really purely from the manufacturing side. All the rest of us are more or less engineering, EBOM, design, and David, you come really from the execution side of engineering, right?
Yeah, it's all manufacturing, all process control, factory automation. I live in what's known as the manufacturing operations management domain. So all the things that the crazy engineers have come up to say, we need to make this, we figure out how to actually execute that work. That's what I do.
Awesome. Well, can you talk about your company too? Because obviously it's the first time on your podcast. And people don't know you.
Yeah, absolutely. Yeah. So Mark Stackworks, Mark O'Donovan and I, we formed it here back at the beginning of the year. We both come from 20 to 30 years of manufacturing experience, and we focus on, as I mentioned earlier, the manufacturing operations management domain. Our claim to fame is we use a standards-based MOM built on a modern technology stack. That's where we fit. So the company really comes in three different flavors. It's the consulting piece that we really help companies figure out what is it that they want to do, what do they want to do, what should they do, what do they do next. Then it's also the solutions architecture of how do we build all the different technologies that we could fit, how do we get that all to fit together. And then finally, we can do the execution of the work as well. So we have a broad team that plays in a lot of those different fields. But that's really our focus is around that manufacturing operations management of getting what we need to make from our ERP, what we call the level 4 system, actually and execute the work on the plant floor. And all the stuff that happens in between.
Yeah, I'm not sure if the other people on the panel know what ISO 95 is and the 5 layers. Does that sound like foreign material to all you guys? You wanted to, David, if you take like 30 seconds, you can explain that stack, because we don't really have that on our side of the world.
Yeah, no, understood. So ISA 95 is a standard that's, it started probably mid 90s. I think its first iteration was around 2000, but really the idea was that we wanted to integrate our business system. So we usually call it your ERP, that's your enterprise resource planning, and we need to integrate that with your control systems. That's how do we actually make that. And in there was what we came out of now, the 4 levels. It was originally part of one of the Purdue Enterprise Reference Architectures. So we always talk about the physical process. That's level 0. You'll have your sensing elements, control elements. That's level 1. So those are like, anything about your thermostat on your wall. What's the temperature in the room? Then I'll actually turn the air conditioning on. So that's
SCADA and PLCs and factory terminology.
PLCs, right? Exactly. And then level 3 is going to be that manufacturing operations management. And finally, level 4. That's all your business systems. I would call that your ERP and your PLM, which I think is what we're going to talk about today. Yeah. But the whole purpose of the standard is to find a common way to exchange that information. And we can certainly get into a little more of the weeds of that, but it really fits in. There's a handful of areas of what it is that we're trying to focus on.
And then you've got
that's the standard.
Connect, collect. What is it? Connect, collect, store, analyze.
Yeah.
So it's
they're all. It's all the journeys of how do we go about doing this. And I think really, if we want to spend a little more time on ISA 95, it's really, there's the 4 domains. So there's always production, maintenance, quality, and inventory. Then there's the 4 types of exchange. So that's the definition of what is it that we do. There's the capability of what are we now able to do if we were going to do it today. Then there's the scheduling. All right, now we want to, that's the plan. That's what we mean to do today. And then finally, there's the response or the performance of, well, here's what we actually did, and that usually is what comes out in your daily shift report of, well, we didn't do a very good job yesterday. Let's try again today.
So I wonder how much of that is our fault over here on the engineering side, right? Poorly specified EBOM.
Well, I'm always a big believer. I mean, we love start by the model. We have to understand what it is we're doing, but I think we'll find out of, boy, when we do that EBOM to MBOM, what does that really mean for us on that factory floor? And they can take on a lot of different flavors.
So who on the engineering side wants to define EBOM. You want it, Patrick? Maybe you give us the academic, your academic definition you give to your students every year, every semester.
Sure. Although the first thing, I'm trying to figure out how to put my picture next to David's because I'm much more out of that realm. I got to the point in CAD I could turn a square into a cube and a circle into a cylinder, and that's as far as I got.
That was about it.
But my background is first factory robotics, and then manufacturing planning, and then exporting, BOM exports to the to either ERP or MES. So yeah. All that stuff. ISO 95. Yes, all over that stuff. So let's see. So in my let's see. I'm going to go back to my time at Dassault. And specifically Delmia, which is a manufacturing process. So they were very big. They are very big on product, process, and process.
PPR.
Process
PPR.
And research, right?
Resources.
Product, process, and
RFLP,
research.
PPR, the V.
PPR, right? Exactly. So the EBOM fits into the product space, but then we need processes to build all that stuff together, and our processes need to work on resources. So a lot of this came out of the 787 project, and the way it was described to me is that products fly away on the airplane and resources stay on the ground, right? Gotcha. So all our machines, and I make the point that really before the bill of materials, you need to think about the bill of equipment. I have to have machines in order to build the if you design something that can't be built, that your design doesn't matter, right? So if there's not a machine for it, then you're gonna need to design the machine first. So in a quick brief recap, I guess I'll leave it at that. Is that the BOM, which would be the product, and the processes and the resources all need to work together in order to get the product out the factory door.
And yes, you've got quite a lot of experience with ERP. You've done a lot with SAP in the past and stuff. Do you have another perspective on it?
Yeah, on BOM exports anyway, and this goes back a decade or more. But yeah, so
well, I was asking Jos actually.
Oh, I'm sorry. Good. Let me get out of
here. Okay. Yeah. So first, an objection to the beginning, Michael. We are not engineers. We are PLM guys, and we cover the whole life cycle.
That's fine.
And then coming back to EBOM, MBOM. Yeah, not every company needs an EBOM, MBOM. And we also have to realize that if you are a typical engineering to order, you already engineer it to be manufactured directly. And so there is not this split. You only would think about EBOM, MBOM if there is a disconnect in your specification phase, which needs to be stable, and you have a flexible manufacturing possibilities afterwards, like, for example, multiple plants, or you have components that have to stay alive for many years, and the suppliers might change. So if you look at the EBOM discussion in the early days when I was working with Smart Team, often when I talked with the customer about the BOM, they thought the BOM in SAP, because only SAP has the BOM, and the rest, in what happens in front, you have to upload your drawings, and the BOM didn't exist. Only later, when I think PLM systems became more mature, we start to say we're going to have a BOM in our PDM or PLM system, and by adding an MBOM to the capabilities, to the data model, it looked like we were doing something manufacturing also. But like Patrick also said, you need to also to manage the resources. You need to know the equipments for your plant. You cannot just define an MBOM if you don't know for which plant you are designing. So that's where a little bit my position on the EBOM. It's the most popular, one of the most popular blog posts since 2008. I think it's called "The Importance of EBOM and MBOM in PLM."
Nice.
So it's a hot topic.
So Oleg, you also came from a Smart Team background, and you actually built a PLM. Do you agree with Jos that there's no such thing, no use for that? There's only an EBOM or only an MBOM?
There is something in this background noise. Is it
Someone was pounding on a keyboard.
Someone is pounding on a keyboard. But I mean, I will use it just to show the book, which goes back before I think Jos to support, if you know this book. Know that book, right? Okay. So that book, even before what Jos said about SAP, this book was saying, like, we need to get one BOM. So this is where I started, and like not about engineering, not about manufacturing, but the whole idea said we need to have one BOM, and then it somehow started to translate it to, wait a second, but what comes from engineering, it's what comes from drawings. This is where so many people, when they come to this point, and the blog that Jos mentioned, and a couple of others, they say, oh, no, that's not the BOM. This is the part list that engineer is sending, and it's in the drawings.
Yeah.
Okay, so don't worry about this. So I think in the later stages, when this conversation between PLM and ERP domain started to emerge, I think it was a topic that I got introduced many years ago, somewhere back in Smartim days. Is that there is a concept that called throw it over the manufacturing wall. So what you throw over the manufacturing wall, it's called engineering BOM. And then if they will make it, then it's going to be something real. And before that stays as the engineering BOM. I think those are three things in connection, but this is, I think, where it is starting.
Ken, you want to throw in your own perspective here, because you're pretty enthusiastic on our internal chat on this subject, right?
Yeah, I'm gonna listen for a while.
All right. Well, Jonathan, you go ahead. Did you want to say something?
I'm not sure that any of the major PLM providers have a consistent long-term strategy for what to do with EBOM and MBOM. When Oleg talks about moving to a single BOM, I'm not sure that any group of people smarter than me, certainly, as smart as, Brion and, Oleg and the rest of you are on this subject, have sat down as a committee to decide how PLM should be reconstructed to enable a more agentic EBOM environment and be able to exploit AI in the process. And so until that is done, I'm just, trying to figure out how to interconnect the data model between PLM, SysML, and ERP to create a more agentic environment. And as I look at all the opportunities for doing that, I ask myself the question, how on earth would AI ever be able to do this? If we interconnect our data model, so for example, if we go into PLM and we take the part classification, parametric part classification tree out, filter it down for all those things you wouldn't use as a physical block in SysML, and then export that tree with all the parametric attributes and use that to derive your physical library in SysML. Well, gosh, now we can, when all those required attributes are filled out on a SysML block, I can run a script that automatically searches for and tags the block with a reusable part. If it doesn't find a part, I can create the correct part type and classify that part. And now, because we're building the BOM as a physical structure in SysML, and all those parts are attached to it, digitally linked, I can now generate the first instance of EBOM from SysML, the earliest instance of EBOM from SysML. Now, that I can extend that example to how we then take that and automatically attach the start part to the part, attach the component characteristics to the start part, automatically launch the material properties into the start part. All that can be done agentically with no user interface. And so I'm struggling with how we're going to use AI to do anything like that.
Interesting. Well, Oleg, before, because we haven't heard from Brion or from Jonathan, I wanted to ask Jonathan, because you play the role of also of a journalist like me doing podcasts. So you speak to also a wide variety of people, and you've also worked with a lot of customers. I mean, admitting that there is a world where there could be only one possible BOM, as Jos said, but in the real world, in most companies, there still is an EBOM and there's an MBOM. And the idea behind this podcast is to say, why the heck are we still doing it in Excel? Because almost every company I talk to, there's something still in Excel. We're not using PLM as the master, or ERP as the master, or MES for David as the master. It's still this gooey thing. Why is that? Is it because we suck at UI? Is it because we 3 different people fighting over the same table scraps? I mean, what do you think that comes from, Jonathan?
Yeah. So let me back up to the definition you asked about earlier, because I think that feeds into that answer. And I'll give you my definition of EBOM and then MBOM, because I think you have to talk about both to sort of one draws the lines for the other sort of thing.
Yep.
So from my perspective, EBOM is the specified elements and quantities of the product, right? As they need to exist at delivery to the customer. So there's a moment in time that definition applies. And that's what engineering's doing, I think.
An effectivity date.
Well, I don't mean effectivity. I just mean that BOM is about how the product needs to look as it gets delivered to the customer. That's what engineers are defining, right? And manufacturing BOM's got a different purpose, a different definition. I think of it as the elements and quantities of raw, in process, and finished materials in groupings of how they get combined to meet that spec of the EBOM, right? So there's sort of 2 different points of them, and I think it gets right to your question. Why do we still have Excel in the middle of all this? And I think the answer is because that translation from one to the other is not simple. And depending on the organization, there's tons of rules, and then there's tons of preferences that get applied. And all of that is really hard to codify. So it ends up that people are like, well, I need a digital tool to do it, to put my own rules and preferences in, and they end up with Excel. That to me, that's what I hear.
Brian, so I'll bring you in by asking you a question that's in the chat. I think it would be a good one for you. Chris McCormack, an old colleague of ours from PTC, asks, could the same reason companies organize their PLM to mimic File Explorer from Windows be it's true, right? I mean, that's what they look like. And in doing so, develop data silos, reducing collaboration, increasing search and retrieval time and effort, preventing valuable data from people who need it? Could it be the same reason that we have those kind of negative behaviors?
Well, that was a kind of an obtuse question, because I'm not sure what the file content contains, right? I don't know. So to not answer that question would probably be easier than to answer it.
Well, is it a mindset thing? Is it just because we're still thinking in terms of the 80s and 90s UX that we've gone to this place?
Let me just give you an example of EMC. They were high-end storage systems, right? EMC.
I remember we were competing with them when I was at HP.
Yeah, they had the most volatile transition of an EBOM to an MBOM, where they would take, and you can just visualize that you've got this system with a bunch of slots, and you've got screws that are holding, boards into slots. And in the engineering drawing, you'd see, the screws actually in position, right? It would be a visual of what that was. But in manufacturing, they would baggy the screws. So you're taking from a BOM the screws that are at a certain point in the hierarchy, the subassembly, and you're taking all of them and you're putting them into a baggie, and you're dropping that baggie at some point, or baggies at some point along the manufacturing work cells, right? And so the manufacturing BOM dispositioned those, and manufacturing wanted to know, how can we take these screws, put them in a baggie, and if you do something in engineering, we knew which screw they took out or changed, right? They might make it longer for the top, shorter for the bottom, right? And so we found a way to be able to make it so that when that child was brought down and put into another parent, the baggie, we would remember who its original parent was on the relationship. That's where I always talk about overloading the link. On the relationship, we would put that value. So now if somebody was to do something in engineering, we could look at, now I found it, it's in baggie number 3. That used to be the child. Now I'm going to swap it out for another product, or another part, or whatever, different material, who knows? And so even back in, I think it was 96, we were able to do this between using Windchill. So that's the PTC guy. Hello, PTC. And it was not difficult. It was very easy. And we found other times where we've done the same thing, where on the link between the parent and the child, you can either go to a quantity of 0 because you're going to move it and it appears somewhere else. But the only way to do that is to label that this is for the MBOM. The MBOM says the quantity is 0 here. Now over here in a baggie, the quantity is 1 and it's new and it's for the MBOM. So if you filter your view using the characteristics that are contained on the link, then you would filter out anything that wasn't the EBOM, or filter out anything that wasn't the MBOM, or even filter out what was not applicable to ECO 1475, or what was on effectivity date, July 2026, right? All those things can be interpreted by the BOM viewer if it had enough intelligence to know what content was on the links. And people could use that to kind of spin the dial. It's almost like, I want to see what's being built today, and swing, I want to see what's being built next month. And you might find you're depleting the inventory of one part and you're going to engage the use of another part. I hope we don't run out, da, 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 da. So I don't see the complexity of this. I wish somebody would tell me how I'm full of crap and define how full of crap is true, because I've checked all the major players and they all have this ability to contain content on the parent-child relationship, which will thin out, expand, or change or morph the BOM based on what your intelligence of attribute data is on the link. So I'll go back over here.
In the balcony. So is it a problem then of pride and ownership? Like, we want to own the MBOM and we want to own the EBOM, or is it a problem of UX where Brian says, hey, all the capabilities are there, we're just not using them? Why is there a disconnect? Why are we even having the conversation? Why isn't it just obvious that all these systems are already working together? I don't have an answer to that. I don't know who wants to jump in.
I don't know that the parent, I don't know that a child in the engineering BOM, the parent of a child in the engineering BOM is in the engineering BOM, a child's parent may be different than what it is in the MBOM.
Exactly. So let's take that back.
You can't overload the links for that. You need to create different parents.
Well, no, you can create a different parent. You got the top level assembly, that's the product. You create a baggie. It's only visible in the MBOM. And then in the MBOM is the screw, quantity 1 or quantity 4. It used to be over here on the subassembly, memory board. It had 4 screws. Those are all zeroed out for the MBOM, and they're brought over here into underneath baggie. You have to always look at the parent-child relationship as, do I traverse it for MBOM? Yes, no. Do I traverse it for EBOM? Yes, no. And if you filter, you can heavily morph between EBOM and MBOM, but the key thing is you want to make sure nothing disappears, right? You can't make something go to 0 and over here have baggie and don't put it in the baggie. You take it away from here and you don't find it in the baggie. That creates a loss of a screw in the baggie. So there has to be intelligence in the BOM structure, viewer, navigator. And I don't know of any major
something
player
missing
that
in the
doesn't have
PLM platform, right?
They have it in the PLM platforms.
So
Or maybe
what
OBOM.
I'm gonna
Open BOM.
Go ahead, Jonathan.
Are you talking about intelligence to manage the transition of rules and preferences between EBOM and MBOM?
I guess you could use those terms. I mean, it's a little more complicated than I was talking about, but yeah, rules. I mean, it's very similar to if you did if you were an NPM link, right, in PTC, and you had a MBOM, and you found that the process steps did not include something that was defined in the MBOM, it should fail. It should say, hey, bro, you're missing this bracket, or you got it in the MBOM, but where are you going to use it? What's work cell?
Right? You have to consume, right? You have to consume all the consumables.
You have to consume everything, or or you can't consume something that's not in the MBOM, right? If the MBOM says I need 20 of these and you're using 25, that shouldn't work, because your work cell use of or consumption of parts should be fully contained in the MBOM, and the MBOM should be fully contained on the EBOM or more, because I might have liquids, I might have grease, I might have some stucco or some who knows what.
I'll give a specific example on this, and it goes to the service BOM. But this is very this is floating airports, right?
Yep.
And they're full of pumps. And in the EBOM, we say we need a motor for this pump. Well, the pump automatically comes with a coupling. In the service phase, couplings wear out far faster than pumps do.
Does it come with the motor? Does the pump come with the motor?
The way it was described to me was the EBOM does not include the coupling because it automatically comes with the pump. However, the service BOM needs to recognize that we need to provision couplings because the couplings are going to wear out. So what I'm getting to is there's different context, there's different semantic context. The way different people think about different things leads to different structures. So the engineers are trying to develop engineering intent. The manufacturers look at this in terms of manufacturing intent. Processes effectively manufacturing intent.
Whoa, you froze, bro.
We lost Patrick.
That's it.
Come on, Patrick. So let me just say one thing while he's floating in the abyss. I don't know where he went. He's in stucco mode. I don't know where he went. That you could take an engineering subassembly that contains things and have those things disappear on the MBOM, right? Because it's a purchased part, meaning they don't even exist. Why? Because you're purchasing the part. Or you can add a coupler. Did you get that, Patrick?
You know what?
You
disappeared.
disappeared.
Lost me before I lost you, and then I lost you for the last 30 seconds.
Jos had his hand up.
Recap my point. The people involved in developing a BOM for engineering intent have different paradigms than those who are developing an MBOM for manufacturing intent, and they have different paradigms than those who are developing a service BOM for service intent. And if we need to bring the structure to align itself with how our workers are thinking. We certainly need reconciliation, which is something that you talked about, EBOM and MBOM reconciliation. But I don't see overloading the links. I think we have different parent-child relationships.
Jos, I think, was next.
I
think Jos had raised his hand, and then Oleg raised his hand. Go ahead, Jos.
Oleg was before, so I give Oleg the stage.
Okay.
If he still remembers the question.
I remember for sure. The
Oleg.
question was building up. I want to go back to what Ken said. I think what we're dealing with is with something that is not a technological problem. So there is a structural problem which is called fragmentation. So the way products are built, the organizations are fragmented, and everything is fragmented there. And no single system, if you have multiple systems, as the entire picture. So this is where Jos came with the ideas when the MRP2 was the only system that was a question how to have one BOM in that system. But as the systems became more systems and PDM systems came, manufacturing systems came, and other systems, no single system see the full picture. And then what we are dealing is that we are dealing with the handoffs. Like every handoffs between those systems create a gap. And that the gap that is filled by Excel. And 30 seconds. So what actually happens is that because of the business model of all vendors is data locking, no one wants to agree that we have a single picture of data because we will lose the business. ERP systems wants to own the data. PLM systems want to own that. Everyone wants to own the data because this is how seats were sold. It's actually changing, separate conversation. But this is where the problem is created. There is a fragmentation, there is a handoff, and the interest of every single one to own this. And this is the place where spreadsheets, and spreadsheets is not because technologically it's impossible to solve. Spreadsheets is because, and that's not because the discipline is wrong, it's just because this is the natural way to fit these gaps in an easy way. And this is how we come in. It's not UI and the UX problem. It's not the data model and data something problem. It's the filling the gaps between systems that everyone holds their position and no one has the entire picture.
Yeah.
That's it. Thank you.
Yes, you're up.
Okay. Yeah. So I think with EBOM, MBOM, we are just focusing on part of the information stream in an organization, pure on the parts. And I think, yeah, Oleg already said most of it. I mean, we use Excel because it's a way to transmit information from one division to another division. And in the good old Smart Team days, I had a project where we created an export in Excel, and then we had on the other side, they created an import in ERP. And then after some months, people in ERP said, why do we need to manually every time upload this Excel? Because the data was correct. It was trust in, is the process okay? But coming back to the discussion also with Brian, I think all these technology discussions on parts and children and parents, actually you should see it as a network of data, connected data, because it's not only the BOM structures, it's all connected data in a certain context.
Yes.
And the better you're able to represent this in a user interface, people understand it, but will they also buy your software? Because that's where also what Oleg said, if you have a system, you want to say, let's do another function to keep the customers, but maybe there is a better system for it, but then you need to be open. And I think that's the challenge we are also facing, openness and access to data elements from different environments.
I know Brian's got his hand up. It just makes me wonder then I guess all the vendors are wasting their time and money building MBOM modules then, right? Because if ultimately it's always going to be done on the manufacturing side, why the hell did PTC even invest in NPM? Like, why did that, what? Okay, Dassault, arguably they have Delmia, so they actually own that piece too. But I don't know, it just seems really messy.
Everyone wants to own this because the business model was to
but
own.
It creates chaos, right? It creates, I've noticed too, like one of my customers, they were asking me, Vino, how do we increase time to market by 50%? And they only showed me the engineering stuff. And I said, well, I can help with the engineering, but if it's just going to grind to a halt when it gets to manufacturing, yeah, but those are those manufacturing guys. We don't know those guys. But how can you look at the problem holistically if you're not talking to manufacturing? Oh yeah, but we don't know those guys. That's a different, screw those guys. How do we fix that? So that's sort of one of the ideas behind the call too. How do we mend the fences and get people talking? So Brian, you were up, and maybe David, you haven't talked in a while, and you're our manufacturing guy. And somehow we lost Mr. Jonathan Scott, unfortunately. So
yeah.
See you later, Jonathan. We'll catch you the next time.
Okay.
Go ahead, Brian.
But as long as we
very
have
quickly,
a serial
I
company,
want to say how you can
I mean,
fix.
right? Just one thing, as long as we have a serial organization, we will work in systems, everyone optimizing their division for profit and loss. There is nobody responsible on the top level.
Brian?
Yeah, I would like to jump up to the top level just for a second, right? So it actually depends on the strength, vision, and collaborative mindset of those at the CXX level to bring engineering, manufacturing, service, customer care, whatever, together and say, you're all working for me. Don't screw up. You're all working for me. Reduce the timeline of, as you said, 50%, which means ideation to manufactured, deliver. So that's how that happens. Is there's got to be strength. There's got to be composure at the top level, knowing that everything underneath is owned by them. Get them working together. Find ways to do it. Have a freaking picnic. I don't know what you do, but the fact is, somebody just turned on an AI agent. I heard that. But nevertheless, I put it in the, all I want to do is say, I put it into the chat, a link to an article I wrote, which goes through the EBOM-MBOM transition and has pictures, so you can even have kids look at it and they'll say, "Oh, look at the little pictures! Isn't that nice?" But give it a read, and you'll see that I can't find a way that the same tool, the same BOM tool, can be used. Here comes Jonathan. Can be used for both EBOM, MBOM, SBOM. Can even be used for, rev something, right? And the key we used to worry about in the 80s and 90s was don't rev the battleship when you rev the boat, right? Which means, how do you rev something and then say it no longer matters? And you got to be able to control that, or engineering is going to have, rev 737 because they did a bunch of changes down below. So you got to be able to manage how that works, and effectivity date is a good way to do that, right? So that you can say, I'm going to swap this screw, let's stay there. I'm going to swap this screw out for a longer one, but it doesn't change the form, fit, or function of the parent. So, don't bother revving that one. So there's a lot of ways to be able to manage in the engineering world. What will then be worked on by the manufacturing world in the same tool, right? And you're always going to have to drop it unless you have NPM link, and that goes back to process management for MES, right? So there's always going to be the need to pull out of the PLM system the MBOM for the day, or the MBOM for this rev of the build. You always have to. It's how you dispense of it, put it into the manufacturing work cells that will, ensure that you get the thing out the door and don't have parts left over, right?
So before I go to Oleg's question, I did want to ask David, because I'm just wondering where and ideally for you should the bill of process exist and be authored? Is that yours, an MES thing, or should it be a PLM thing? Where should the BOP go? And the BOP, does that include the work instructions, or that's yet something else, right? So that I wanted to throw that to you.
Yeah, no, these are all great questions, and we get asked this a lot of, around ISA 95 and even around using, say, this agentic AI of how can we take that standard and then use it and consume it. And really, it's more of an art than it is a science. So when you talk about having the engineering BOM, what are we going to work at is how do we now actually translate that to how we actually make things in this factory versus that factory, and they could be very different. So that's where we get into the art of how do we want to go about not just taking the resources, those are the physical things that are going to exist on that BOM, that bill of materials, but now how do we work that through using all of our activity models or the various ways the activity, I don't want to define activities model saying activities, but the things that we're doing, how do we now translate that, which is what you now get into that the manufacturing BOM. And where you get into work instructions, it all depends on where do you want that to maintain. So just a couple of comments going back is when we talk about the data model, something that we do at AMARC is we abstract that data model, and we call it master data management or master data modeling. Is we want that to be in its own separate system. So regardless of what you're using, and I realize it's not as easy as, it's easier said than done, that whatever system you're choosing to use, that's okay. It doesn't own it. And the reason why we don't want that owned in a system that is, say, proprietary is because if you decide to change that system, now all of a sudden you're beholden to it, and you want that model to be available to everything else. So, and that's really around just how do we want to persist it. But where we really get the magic within the standard itself is on that exchange of information. Is there a mechanism that EBOM to MBOM to SBOM to work instructions, how do we actually make that happen in a way that is seamless and common? Because everybody wants their own sandbox and nobody wants to play well with others. And we run into that a lot. So, for us, it really depends on how the manufacturer wants to manufacture, what tools exist to do it. And that's where we would get into the whole, this is how now we're going to model both the persistence of the data as well as the exchange of the data. I hope that made sense.
It made sense. Oleg, your turn.
Yes, thank you. The question that I wanted to try to answer again, you asked why the Excel exist. So, and an example that Brian started to bring is like how we can own the whole. But the problem is that those systems are disconnected by nature. So you might have multiple manufacturing systems in the different facilities. You can have multiple manufacturing sites. They will be working independently. And the engineering still will be centralized. So that would be one example when you will be sending those Excels, and people will Jos example was excellent in my view, because people build those interfaces and they're actually using these interfaces for control. So they use interface to validate that the right data goes to the right MRP system or right ERP system. So they say this is the barrier to check. And they made those check based on the Excels. We want it and we like it and we don't, because they want to have it separate and they want to check the border. So the same happens in another use case, which is not a single company, but the contractors. So the contractors are holding the position and saying, send us Excel. You come to them, like we have a customer that said, we came to them and said, we can integrate directly to your SAP. They said, don't. They said, why don't? Is because we already built the process. No one wants to teach people. No one wants to do anything new. We already have the process check in Excels. We already wrote utilities and tools that will validate that nothing wrong comes with this Excel. That's why please build the same Excel we had for the last 15 years, and this is how we continue to work. That's the reality. I mean, nothing wrong with the technology, just the organizational reality. So the answering question, Michael, that you asked at the beginning of this, like why Excel exists, is because it fills the gaps of the realities of the organization and the way they want. Can we build it better with the better data model, like David explained? Yeah, hell yes. Everyone has now better data models. Try to bring better data models to organizations that still want to stay in Excel, because this is how they validate it to work. And technicians do not want to learn any other tools because they said they understand Excel. If you send them another tool, you need to guide them and it costs money. If you send them Excel, they know. And the last one, that the most funny and the most fascinating, and I discovered it. When you give to someone access to the tool, you take liabilities. Because they will come, like contractor can come and say, I've seen something wrong in your tool, and that's why we build it wrong. So when you send them Excel, you take liability off, and you say, this is a freaking Excel that I sent you. You did, and I have a trace of this Excel, by the way. And you build it wrong, and here is the email that's sending you this Excel on this date, on this time. So now you need to pay this $50,000 for break and build, and not me. So many interesting organizational questions, nothing about technology.
So it's really a human problem, not a technology problem then. Brian, you had your hand up?
Everything you can take.
Yeah.
And then maybe Jonathan, before you disappear again, we'd like your input.
Jonathan, why don't you say something, because you floated away.
You had your hand up. You had your hand up before you disappeared, actually.
I did. I'm too tired from running away and running back and running away and running back.
Boy,
technology
is tough, man.
Yeah, Oleg, I disagree. Technology is the problem. It's webcasting technology that's the problem. But anyway, yeah. So I don't even know what the question is, but I'm going to chime in with what I think the question is. Some of what's behind all this, right? What's causing it? And I have an opinion, and hopefully nobody shared this while I was gone. I think it's about a fundamental problem we have in PLM today is we say product lifecycle, and we only handle the engineering piece primarily. I mean, we touch on quality, we touch on manufacturing, but I'll give you an example of what I mean. We still call it engineering change, right? I think
and not enterprise change.
And what it needs to be is enterprise change, or I would call it product change. We're changing the product, okay? But in that concept, we have this legacy CM idea of engineering release. Engineering release is a moment. It's a point in time that matters to the organization. I totally agree. But that's not really what you need to get the product out the door. Which is why we have these debates about ECO, MCO, engineering change, manufacturing change, and we don't have the enterprise change we're talking about. Not to say systems aren't capable of it. Like Oleg said, technology, it's possible. But what I see in a lot of organizations is they're stuck in that mindset of engineering release is the moment in time. Well, if that's the way you think of it, of course, you're going to have a gap to the manufacturing side and the execution side. Similarly with service, if that's part of your business. But if you look at the whole process and you don't think it ends at engineering release, then you think about how do you get this data from one stage to another. To me, that's got a lot to do with the gap we see.
Good comment. Thank you, Jonathan. I think that, yeah, Brian, yeah, and then Patrick, and then Jos, I think.
Yeah. So, Oleg, to your distributed factory issue, and keep them lean, mean fighting machines, send them Excel. I did something back in the early meaning 01 to 05, where we built a product called Flex PLM. And my company sold it and the technology to PTC in 05. That product had to deal with a whole slew of distributed manufacturing, right? Especially for footwear, because whoever manufactures the shoe is the company who has the last in their possession. You know, the last comes first. The last is the actual foot form. And then they wrap things around it and get yield on what the vamps will be versus the tongue versus the cap and the etc. So the factory's in PLM, Flex PLM, to actually build the BOM, because they're the only ones that know what the BOM's going to be. They're provided an image and they wrestle with that back and forth, but no engineering is done by the boot or shoe designers, except defining its last, which then targets the factory. On the apparel side, it's totally different. The apparel side could have 2, 3, 4 different manufacturing facilities. And every time you do a BOM, you could have one colorway of the shirt you guys are wearing. One colorway goes to one factory, but because it's going to go to another factory, they have a different supplier for that material. It's the same material, different supplier. So the BOM in Flex had to be able to take into account the variances of these different manufacturers. And so therefore that was done by the developer in the brand company. So all I'm saying to you is, if you want to harmonize what you're doing, you can infiltrate, the factories into the system and have them work on the BOM, or you can push out the BOM in a tech pack, like in apparel, which says specifically, here it is, and we know about your factory, we know about your supplier, and we took it into account, right? So PLM can be used in that thing, where we talked about the isolation and silo of organizations. That is an impediment if you're in the same freaking company, your engineering and your manufacturing should say, hello, we're over here. Can we use the same system? Yeah. Don't disturb my stuff. I won't. Set up protection so that you can only do certain things. I know you're shaking your head, Oleg, but all I'm saying is it can be done. It can be done. And yet, because we're still dealing with the gray hairs, see the gray hairs? That's me, gray hair. A lot of you guys are gray hair, right? They don't want to change, right? They want to stay the way they were. They want to have that barrier of liability, Excel, but it could change. Okay, that's all I'm saying.
Patrick.
And then to Ken, one last thing. And to Ken's point, you could have AI rumbling through these BOM structures to automate the EBOM to MBOM transition by flavoring the links on some rule-based process, and have manufacturing people change that later, but set it up for them. You could do that too, right?
Patrick.
I'll bring in the book. Oleg brought in a book, right? I'll bring in the book I read most recently. This factory, the
Here's a book. Here's a book.
Okay, one at a time.
Here's a book. The author of this one.
The Ford family built more aircraft than Boeing could imagine. I mean, in the amount of time that they had. However, they didn't care what happened after the plane left this factory, and they didn't care what happened to their Model Ts after the Model Ts left this factory. And we're moving into new societal norms where customers, governments, and society expect the OEM to maintain continuity throughout the entirety of the product lifecycle. And PLM is not up to this job. PLM is an important piece at the beginning of it, but it's only a small piece of this job. And I'll bring us back to a conversation that many people in this group had in this group on the 737 MAX, where Boeing was not big enough to keep the Boeing planes flying. They are relying on their airlines to do proper maintenance and their airlines to do proper pilot training. So as we start looking at the entirety of the life cycle, we've got to talk about digital threads. PLM is not capable of accomplishing what society is expecting out of its products. If you look at what we talk about in my classes, the 737 MAX, we talk about the GM ignition switch. If you look at a variety, we look at the Flint water crisis, if you look at a variety of things, society expects a lot more than what society expected in World War II. So the CEO is not big enough. I mean, the CEO does not have enough scope to manage his life cycle. We have this multi-tiered system that's just not capable of doing the job. I see when you introduce a new product, you need to introduce the thread. You need to introduce the entirety of the thread, from lust to dust, from the first concept of why we want to build this product till when all the final come out of service, right? We need to build an IT infrastructure that can manage the entirety of that life cycle, and that would be the thread. And then at this point, the different BOMs, the thing that we happen to be talking about today, are views into that thread. So engineers have a view into the thread, which is specific to their purpose. Manufacturers have a view into that thread, which is specific to theirs. Service people have it specific to theirs, et cetera, et cetera. So I kind of wrap up with that and say, I mean, this is a useful conversation at the beginning of the life cycle, but it's, I guess what I want to get to is we got to build the thread first. That we don't have the ability to build the full solution from the limited perspective that we're currently discussing. Well, that'll stop.
But who's going to own the digital thread? That's the thing. It's the agents. It's an agentic.
Boeing has lost $39 billion since the first crash. So I don't think there isn't. I mean, our business models are not. We do not have business models aligned with society. What the future societal demands. Society is beginning to demand things that we simply don't have business models to accomplish. And because we don't have business models to accomplish, our largest companies are struggling. And Boeing is the
poster child.
Thank you. That was the word I was trying to come up with. Boeing is the poster child at the moment. It's just going to keep growing.
Jos had his hand up.
Different business model that's needed. Okay, I'm sorry.
Okay. So yeah, thanks Patrick, because I wanted to react on Jonathan's engineering's change management and engineering release importance. But I think also, Patrick, you already said the important thing that from the beginning, for me also PLM was about the full life cycle, and it was not the linear process of pushing something to the market. It should also have feedback loops. And one of the lessons I learned even in the 90s, previous century, is that the engineering release is not important. It's about a stable engineering definition, so manufacturing can build upon it and to have the product release. And I think from the beginning, there was always this discussion, okay, engineering is stable, now let's start with the manufacturing definition. That's the old traditional linear process. In a modern approach, you have already manufacturing looking and contributing to engineering reviews. We were not able to do that in the old ways because we had our own systems and we waited till it's ready, like we do. Wait till I'm ready, then you get your job. But historically, for me, always the intent in discussions was it's an enterprise process, and it's the same for configuration management. They face the same challenge. Some people think configuration management is only engineering job, and that's where you come back with your story, Patrick, about the life cycle of a product, how important it is.
Thanks, yes. Oleg.
Yeah.
And then Kenn hasn't talked to a while, so let's give Kenn a chance. And then I'm going to ask, we'll do a hand raising. I got a couple questions to do some voting. Like, remember Rob with his thumbs up, thumb down? We'll do that to end. So Oleg and then Richard, and then we'll do the thumbs up.
Yes, thank you. Thank you, Michael. I was listening, but here's my observation is that we have no doubt have technical capability to organize this information in the way so it will be connected and logically organized. And there are many examples of products that built 20 years ago, and now it's all possible. So the reality is that fragmented organizations, and there is no power to pull everyone top down to organize it. This is what I've seen many times. The reality in the field is that when you need to send something to contractor, Excel will be used. The reality between ERP and another engineering system, when they need to do it, they will pull Excel. I mean, this is the realities. Now, what I want to bring, now, we can try to organize everyone, that people do not like to be organized top-down, and engineers don't like to be organized even more, because when you have two engineers, you have three opinions how to send this bomb. So that's the problem. So now, but I want to bring kind of observation from the market and what other companies were doing. Like when Google asks everyone, we don't care what you put on your website, we will index it. And then we will be able to align this information. Now, pull 20 years line to what is happening now. We have, speaking of AI, agentic capabilities to access any browser and to do any work in this way. So pulling information, organizing information, making alignment logically is becoming much more easy bottom up. And that's the only way that we'll be able to capture information, align this information, and program the tools that in the field that no one wants to change. Because if someone invested in PLM 15 years ago, millions of dollars, they don't want to change it. And the ERP system don't want to change it. Now, the economics of this becoming possible, and the indicator that this is possible to build it bottom up, it's because the stocks of the system of records are going down. Why? Because all the system of records now are becoming dumb databases. And before we thought it's the smart databases, single of records, and now I'm becoming dumb databases. And this is where we're coming to the way how we can pull this data and to make something smart. Product memory, if we already want to say this word.
Well, that's on the next podcast, right?
That's in the next
Ken?
one. That's a building bridge.
Ken?
Yes, thank you. So I wonder if part of the problem isn't the incremental implementation that we've seen every client go through over decades, none of them with a long-term set of objectives for a process, equipment, and product. If you just recently, we talked we're helping a client that wants to implement document management to manage all their engineering and manufacturing documentation in the DMS functionality in SAP. And they were struggling with how to do that, and they had a number of crazy models. And we simply said to them, look, what you have to do is look forward. And in this case, we said, you guys are going to do technical data publishing, put together technical data packages. Technical data packages are unique based on part type and on sourcing methodology. And so that's an example of where a customer would have built a data model in a system without thinking about a long-term objective. And then when they finally got the technical data publishing, they'd have to reconfigure the whole system and then manually transform data to get all the legacy parts to work. And that costs too much money. And so they build prohibition to advancement in their incremental approach. In the AI world today, what we're saying is, okay, let's build a meta layer, and we can do all kinds of things with to better synchronize and rationalize and interconnect data through a meta layer. And I wonder if that's the wrong thing to do, honestly. I'm wondering if we should go back to CRM, ERP, PLM, and define a much more specific set of objectives for interconnectivity that will drive very specific processes that are high value adding, and re-engineer the master data model and align the master data model across those three critical platforms. Because if we do that, the necessity for a meta layer will largely go away. It may completely disappear, and we may be able to run everything then from queries and do
We were
everything.
trying to do it for the last 25 years. Exactly what you said.
Yeah.
So let's do the thumbs up exercise. Which of these metrics matter the most? Engineering change to shop floor implementation time.
So again, engineering changed the shop floor.
Implementation time. You do a change in engineering, and how long does it take to actually be implemented on the shop floor? Thumbs up or thumbs down on that being super important?
Well, that is, yeah.
Okay. Number of manual BOM reconciliations per release.
I'm sorry. Ask that same question in reverse.
Okay. Shop
From
floor implement.
manufacturing change to engineering update.
All right. I found a problem. This isn't manufacturable. I need an engineering change to fix the original design.
No, I didn't manufacture it the way you said. I did something else. When does that get rolled back into the engineering documents?
Oof.
Why did you do something else?
Who told you to do that?
You bastard!
Remember when I talked about floating airports, right?
Yeah.
This is the story brought
By
to
the
us.
way, Patrick, I say when a thing is serialized, the snapshot of that bomb should be set aside and used as a serialization of that airplane. And as you service it, that bomb should be changing, not affecting the standard bomb.
I'll tell you, the fundamental issue is the engineers don't know how to build the product, and manufacturing will make decisions on the floor because the engineers don't know how to build the product. So what's the feedback loop until the engineers learn how to build the product?
That's very important.
That's
like super critical. That's like thumbs up, two thumbs up.
Maybe they can talk together.
And maybe they can talk. Yeah, right.
Have a meeting room.
And I was told it was 2 years.
Yeah. Number of manual BOM reconciliations per release. How many times actually had to be done by hand rather than automatically? Okay, that one doesn't seem.
So what are you asking? Is it important?
No, is
to not
that
do
super important, or is it just whatever? We're just trying to find out the metrics that are the most critical in terms of how we're going to
Say it
get
again, manual what?
manual BOM reconciliations per release.
Post
I'd say that's
identification of issue or pre-identification of a real issue on the plant floor.
Might be
Yeah.
what Patrick's talking about as well.
Yeah, that might be Patrick's thing. How about the number of spreadsheet-owned manufacturing structures?
Wait, what was that?
Manufacturing structures are owned by
Word?
spreadsheets rather than by the MES or by the PLM.
What question are you
Replacing the
asking?
spreadsheets or using them?
What does
What-
thumbs up or thumbs down mean?
Whether it's an important
I say you
metric
shouldn't be
or
doing that.
nobody
I say-
cares. Apparently, that's
Not the
nobody cares.
spreadsheets. I say
Well, I
get
mean, I
rid of the
think it's an
spreadsheets.
important metric, but one of the comments I was going to make earlier is that within the MOM space, a manufacturing execution system, that MES oftentimes means massive Excel spreadsheet. I mean, that's just the reality.
Well, they do what they do.
Yeah, exactly, and that comes back to why does the plant floor do what they do? Well, production is king, and they're charged with, hey, you got to get this product out the door. They're going to do what they have to do, and if it doesn't follow the exact thing, it's I ran into this in maintenance. Of you were talking earlier about the service bomb. It's I know better how to maintain the equipment or work on this stuff. So I
Exactly.
think that's just the reality of
Wouldn't it
it's
be
not just the disconnect of systems, it's the disconnect of people.
I think people are the problem. I think people are the problem. They need to get fixed.
No, our company's dysfunctional because I know. I mean, that's just the reality.
Well, I really had a good time on this discussion. I hope you guys had a good time too. That was fun.
Yes.
Next time, it'll be in a week. We'll have a discussion on the topic that Oleg very timely, in a timely manner brought up, which is product memory, which is sort of a somewhat new concept that was thrown around by Oleg and presumably by other people. But Rob McAvaney, the CTO of ARIS, mentioned it at ACE last week. Rob will be actually joining us as a special guest, which will be really cool. David Schultz of TCS will also join us to give us more of a from the field experience, because he's his consultants, his 13,000 consultants are working with customers every day on these kind of things. So it should be a really good talk next week. We're changing the rhythm a little bit because I've got more travel coming up, so I wanted to get a couple of these in. Many thanks to my panel. It sounds like we didn't quite get to a conclusion, so maybe this MBOM, EBOM thing, we can hit it from another angle another time in the future. What do you guys think?
It's something from the
Yeah, I
past.
think that's
Okay.
Let's try MBOM to EBOM. Let's try EBOM
Okay,
to
we go the other way.
Let's try in
We'll do
reverse.
Patrick's thing. How do we
Design
get the
for
manufacturing
manufacturability.
problem back into the EBOM, right? Yeah, maybe we have to go the other way this time. Thanks,
You know, they
everybody.
say design for manufacturability is the key. That's what Patrick's talking
Yeah,
about.
exactly. Yeah. Well, that's one of my theories is that the engineer of the future, all that stuff's going to be compressed, right? When you're designing something, you have to be thinking about simulation and manufacturing. You're not going to be able to delegate that to later on because it's just too expensive and it's killing your time to market, right?
And as Oleg says, we've
I
been
think you
talking
should
about
use the
that
same
for the last
bomb.
95 years.
Yeah.
Use the same bomb. Use the same bomb. EBOM, MBOM, service bomb, bam.
Oleg,
like I said-
Oleg, can you point us to some information that we might read ahead of next week's product memory conversation?
Oh yeah, that would be a great idea. Put it on
Yes,
the put it in the chat of the podcast, and I'll be once again that we're sponsored by AWS Marketplace. There's a link in the chat on downloading a really cool white paper with about 15-20 experts about agentic AI, which Richard tried to allude to, and we didn't quite go down that rabbit hole quite yet. So we'll see how we handle this the next time around. Once again, thanks to everybody. We'll talk to you next week. And thanks again for another great podcast of the future of PLM. Ciao, everybody.
Okay, run.
Thank you.
Leave it there.